Okay, the following flashcards are for inferences on the AP Statistics exam. In order to get a 5, you should be able to have all of these memorized and know how to solve them either by hand or using a calculator like Desmos. So starting off, we have the confidence interval formula for a one sample t interval for mu. Okay. Here's the formula, x bar plus or minus t star times s over the square root of n. Remember, we can go on Desmos, add an inference, and go to t-test and click on one sample for this. Test statistic formula for one sample t-test for mu. Okay, here is the formula. Okay, in order to do this on Desmos, again, you're going to go to t-test. Okay, once you add an inference, and then you're going to go to significance test. The difference between this one and this one is this one's confidence interval and this one's significance test, but they're still using a t-test on Desmos. Confidence interval formula for a one sample z interval for p. So this is the z interval for proportions. Here's the formula. Remember, when you are checking the large counts condition for normality in the conditions, make sure you use p hat and not p. In order to find this on Desmos, again, you go to add inference, and then you're looking at z-test for proportions. Next one is test statistic formula for a one sample z-test for p. Here is the formula. Remember to use p naught when checking the large counts condition. Okay, again, this is a z-test for proportions on Desmos. Confidence interval formula for a two sample t interval for mu1 minus mu2. Okay, this is going to be very similar to the formula above. This one tells you how to do it on the calculator, but for Desmos, again, you're still going to use a t-test when you add an inference. So add an inference, click on t-test, which is under inference for quantitative data, and then you're going to go over to where it says sample 1 and sample 2 statistics to type in your sample size, mean, and standard deviation for both. Test statistic formula for a two sample t-test for mu1 and mu2. Okay, on Desmos, these are the exact same. The only thing that's different is once you create a test, you're going to do the drop down for confidence interval for this one and significance test for that one. Confidence interval formula for a two sample z interval for p1 minus p2. So for this one, anytime you see p, you know it's proportions. So you're going to go to inference for categorical data. You're going to do z-test for proportions, and you're going to make sure that you type in both samples using the statistics given in the problem. Test statistic formula for a two sample z-test for p1 minus p2. Okay, same exact process I mentioned for this one on the calculator. The only difference is on the drop down for this one, you're clicking on significance test, and this one you're clicking on confidence interval. Okay, next, test statistic formula for chi-squared test for homogeneity and independence. So here is the formula. The only thing that you need to do differently is you're going to look under inference for categorical data. And since this is for chi-squared of independence, you're going to click on chi-squared test for independence. You're going to type in your matrix of data. So your data for group 1, group 2 to group A, group B, type all that in and you would get your answer. Test statistic formula for the chi-squared test for goodness of fit. Same thing, you're going to go to add an inference, and you're going to go to inference for categorical data, and you're going to click on chi-squared goodness of fit test. Confidence interval formula for a t interval for slope. Okay, this is important to remember because sometimes you may not be given all the information, but instead a computer output of all the data. So remember, b is your slope plus or minus t star times the standard error of b. Standard error of b is going to be if given that computer output on that table. Test statistic formula for t-test for slope. Okay, another good one to know, especially if they give you information for a computer output instead of the data itself. Both of these can be done on Desmos. Most likely for these, they would give you the regression line. You would type in that regression line and be able to go from there. Point estimate and margin of error. Okay, point estimate and margin of error, both for confidence intervals, look like the following. They could say point estimate plus or minus the margin of error. That would be the first one that you see. Or it can be written, I believe this is how it's written on your formula chart, statistic plus or minus the critical value times the standard error of the statistic. The statistic is always your x bar or your p hat, depending on mean or proportion. Your critical value is either your z star or t star value based on the distribution. And your standard error of statistic is whatever your standard deviation is for that problem. How to find the point estimate and margin of error given a confidence interval. So it says, suppose the confidence interval is A, comma B. The point estimate is the average of A and B. So we would add A and B together and divide by 2. To find the margin of error, we subtract the point estimate from the upper bound. So once we find that average, we're going to subtract it from B, the upper bound, to find the margin of error. Very, very important, very common multiple choice. Type 1 and type 2 error. Remember, a type 1 error occurs when the null hypothesis is true but is rejected, and a type 2 error occurs when the alternative hypothesis is true and the null hypothesis is not rejected. So false positive, false negative. Power. The power of a test is the probability that a test will correctly reject the null hypothesis given the alternative hypothesis is true. Remember that the probability of a type 2 error is 1 minus the probability of power. Interpretation of a confidence interval. We are C% confident that the confidence interval from blank to blank captures the population parameter in context. Remember, population parameter could be the population proportion. It could be the difference in population proportions. It could be population mean, the difference in population mean, and then the population mean difference. Definitely understand the difference between all of these. Interpret the confidence level. Confidence level and confidence interval. Notice there's a difference. So confidence level says if I repeat this multiple times with the same sample size, approximately C% of the confidence interval created will be captured by the population parameter. Interpret the p-value. A p-value is the probability of obtaining a test statistic as extreme or more extreme than the observed test statistic when the null hypothesis is assumed to be true. Remember, if the p-value is low, we reject that hoe. That's what you need to remember. When the p-value is low, we reject that hoe. And if you don't have a p-value to compare, let me rephrase that. If you don't have an alpha to compare the p-value to, remember alpha is always assumed 0.05 if you are not given any other information. Okay, next is what is an unbiased estimator? It says when estimating a population parameter, a statistic is unbiased if the center of the sampling distribution for the statistic is equal to the population parameter. Okay, so if the center is equal to the population parameter, it is unbiased. Next, conditions for a one sample t-test and t-interval for mu. Remember, you're always checking if it's random. The 10% condition, as long as it's not an experiment. And remember, 10% condition is your sample size has to be less than or equal to 0.1 of whatever your population size is, and that is written in words. Then you're going to prove normality. You're either going to prove it by saying it's a large sample, so your sample is greater than or equal to 30. That is by central limit theorem, CLT. Or if you can't prove that, then you need to draw a histogram or a dot plot, and you need to make sure you show that there is no strong skewness or outliers in order to prove normality. Okay, conditions for a one sample z-test and z-interval for proportion. It's still going to be random 10% and normal, but the only difference is for normal you're using the large counts condition. So remember that is NP is greater than or equal to 10 and N times 1 minus P is greater than or equal to 10. Conditions for a two sample t-test and t-interval for mu1 minus mu2. Okay, notice that these are all the same. You just need to make sure you do random 10%, which is independence, and normality for both of them. So both for mean 1 and mean 2. Conditions for a two sample z-test and z-interval for P1 minus P2. Same exact thing, you're just checking for both samples. So random for both samples, 10% condition for both samples, and then large counts condition for both samples. Okay, remember if any of these conditions are not met, you need to make sure in the conclusion to say proceed with caution. Okay, I'm going to pause here and make another video continuing the flashcards.